Okay, ladies and gentlemen, that was I thought that was kind of interesting because we're talking about proportions, different things, so on and so forth, and I believe that's a Russian doll that you can see. Like, I think you've probably heard of them before, but there's a large one, and then within the large one there's a medium one, and then there's like, it just keeps getting smaller and smaller. And some of them are very elaborate. It's pretty interesting. It's cross-cultural, but you get the idea. So today we're going to take a look at similar polygons. When there is a correspondence between two polygons such that their corresponding angles are congruent and the lengths of the corresponding sides are proportional, the two polygons are called similar polygons. Alright guys, taking a quick look back to what you guys did with your similarity investigation, proportion investigation. When you guys took the protractors and looked at all the different angles for your projects, you noticed that they were very, very similar. That's because they should be congruent. The reason they might be a little bit off is human error, but they will be congruent. Now all your sides must be just increasing by a constant. Alright, so let's take a look at that today. Use the information given to list all pairs of congruent angles and write the statement of proportionality for the figures. Alright, so as far as angles go, I know that angle S is congruent to angle J. How do I know that? First and first, here and here. I can say that angle T is congruent to angle K, second, here, here, and lastly angle R is congruent to angle L, okay, last. Now, statement of proportionality, what this means is I'm going to compare all of my sides. The only thing to be careful about here is you have to be consistent. So I'm going to go from small to big. ST is compared to what over here? JK. I'm not just kidding about that. Sorry, I can't resist. Now pick a different side up here. How about TR? What's that compared to down here? KL. And lastly, my third side, SR, JL. This is known as the statement of proportionality. Okay. Now, you're wondering, I went from small to big. What if you went from big to small? You're fine as long as you're consistent. What you're going to find out is that all of these fractions must be exactly the same. In order for these to be similar, they have to be congruent. That's what we're looking for. Okay? Alright. So, down here, number 2. Decide whether the figures are similar. If they are similar, write a similarity statement. You need to have all the angles be the same, and you need to have all the sides be proportional. So the first thing we want to do is take a look at the angles. Angle A is congruent to angle N. Totally. Okay, how do I know that? They're both 90. These are both double, so that works. So just to write this down real quick. Angle A is congruent to angle N. Angle T is congruent to angle R. And we've learned this before, but if I have two angles congruent in a triangle, the third must be as well. So I have all angles congruent. Woohoo, alright, good deal. Now, go small to big or big to small. I'll go small to big. 6 over 9. How am I doing this? I'm just comparing similar sides. Equals 8 over 12. Boom, boom. Equals 10 over 15. I got to reduce these down. Guys, you can use your calculator if you need to. 6/9 reduced down to 2/3. 8/12 reduced down to 2/3. I'm dividing top and bottom by 3 here, top and bottom by 4 here, top and bottom by 5 here. Does 2/3 equal 2/3 equals 2/3? Yes. So now, a similarity statement is, I can say triangle MNT is similar to triangle XAR. Just like we did before, you want it to go in the appropriate order. And by the way, guys, this might be a new symbol for you. Little squiggly line means similar. Should have pointed that out up top, my fault. So make a little side note here, put little stars. We saw it up here. Okay, and I didn't really point that out, my bad. Now I can only do this if all the angles work and all the sides have the same fraction. Okay, so let's take a look at part B. As far as all the angles go, all angles are right, therefore congruent. Okay, I don't have to keep saying they're all congruent since they're all 9 degrees, and we know that. Now you'll notice that I have 2 pairs of 10s, 2 pairs of 6s, 2 pairs of 8s, so I don't have to do every single one. We can just do, let's do small to big again. 8 over 10 equals 4 over 6. If you really want to put 8 over 10 again and 4 over 6 again, knock yourself out. I don't have to because, again, it's going to be the same ratio. 8 over 10 I can reduce down by 2. I get 4 over 5. 4 over 6 I can reduce down to 2 over 3. Are those the same fraction? No, not similar. Okay, so here's an example of both. One where it works, one where it does not work. Okay, and it's all just reducing down fractions. And again, if you do big to small as opposed to small to big, all it's going to say is over here you'll have 3 over 2 equals 3 over 2 equals 3 over 2, which is fine. You'll still see it's congruent, or similar rather. Over here you'll get 5 over 4 equals 3 over 2, which is fine. Okay, so just because I'm doing it this way doesn't mean you can't do it your own unique way. Alright? Wonderful. Down low. If two polygons are similar, then the ratio of the lengths of the two corresponding sides is called your scale factor. This is the big key word. I think you guys have heard me say this before. The scale factor is something that you can multiply either your large object by or your small object by to get your other object. And we can only do this with similar polygons. Okay? You guys learned this or you found this out for yourself when you did your similarity investigation. Okay, you have a 4-inch by 6-inch photo that you want to use for class election posters. You want the enlargement to be 26 inches wide. How long will it be? Okay, well I'm making a ratio up here, or rather a proportion. Here's my width, here's my length, here's my width, here's my length. I can say 4 over 26 equals 6 over x. And we can go ahead and cross multiply here. Okay, cross multiplication is going to be one of your best friends in this unit. 26 times 6, 156. Okay, divide both sides by 4. 39, and I need to have a unit, inches. Okay, please not forget your unit for any word problem. Alrighty, good deal. Theorem 8.1. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So you guys kind of found this out for yourself as well. I asked you guys to figure out the perimeter of all of your objects. And the scale factor there is also going to be the same as what the scale factor is for your sides. So let's take a look. In the diagram below are shown polygon ABCD, boom, 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 is similar to GHIJ. Alright, so 11, 11, 8x. Y8, if this is 5.5, this has got to be 5.5. Find the scale factor of polygon ABCD to polygon GHIJ. So I'm going to compare. I'm going to pick a side from over here and compare it to a side over there. How do I know what to do in that order? Well, this one first, hence this one goes on top. So I'm going to pick 11 because the one over here I have a number for as well. 11 over 5.5, okay, which reduces to 2 over 1. So we can say a 2 to 1 ratio. Okay. Now, find the scale factor of polygon GHIJ to polygon ABCD. Don't overthink this. Now I'm picking a side from over here and putting it over that. Again, how do I know that? This is first. The first one goes on top. So it's 5.5 over 11 equals 1 over 2. So it's a 1 to 2 ratio. Now guys, if I ask you a question like this, hopefully you recognize that you can just flip this around, and I'm cool if you do that. Find the values of x and y. Now, what you could do is, I could set up another proportion and, solve for x and whatnot, but I know it's a comparison of 2. So if I want to find x, okay, all I got to do is times 8 by 2. So x is 16, and then to go from here to here, I got to divide by 2. Y is 4. Now to show you that real quick, I can do x over 8 equals 11 over 5.5. Cross multiply. I don't care if you do this or not. X equals 16. Boom. And then over here, the same thing. I can do 8 over y equals 11 over 5.5. Let's see. 5.5 times 8. 44 equals 11y. Which you get your 4. Okay. So if you want your work, there it is. Find the perimeter of each polygon. So for ABCD, my perimeter, I'll call it PABCD. I add these up. Let's see here. I got 16, which is my bottom one right here, plus 11, plus 11, plus 8. so it's 46 units. The perimeter of GHIJ is 5.5 plus 5.5 plus 4 plus 8, 23 units. Okay. Find the ratio of the perimeter of ABCD to perimeter of GHIJ. So again, the first one goes on top. It's 46 over 23. You'll never guess in a million years if I reduce that down. 2 to 1, 2 over 1 gives us 2 to 1 ratio, which makes sense because we found for part A. Okay, so perimeter, you have the same ratio. It's basically the big thing I want you guys to get out of that. Alrighty, very, very good. Number 5, the ratio of one side of a triangle ABCD or ABC to the corresponding side of a similar triangle. A, B, C, D, E, F. Okay, is 5 to 8. The perimeter of triangle DEF is 96 inches. What is the perimeter of triangle ABC? So they're saying the ratio is 5 to 8. That means here it's 5x, 8x. Okay. And the perimeter of DEF is 96 inches. So what's the perimeter over here? Okay. So what you can do is I can go ahead and set up a ratio. Now, you could do 5x over 8x equals, I don't know what this is yet, okay, so I'll call this y over 96. Now, to make your lives easier, what can I do with these x's if I'm dividing by them? Cancel them out, okay. Now I can cross multiply. 8y equals 96 times 5, 480. Divide both sides by 8. I get y equals 60. So my perimeter is 60 inches for triangle ABC. Okay, it's just bothering me. So again, you're setting the ratio up. Honestly, if I was setting this up next time, I would probably just say, since it says 5 to 8, that's just the ratio. I wouldn't even put 5x over 8x, just put 5 over 8. But you can see they cancel out either way. So here's an example of looking at some polygon shapes using our similarity. If you have any questions, feel free to ask. As always, keep up the good work and good luck. We are all counting on you.